So we looked at that. Now, in the case of marks, coming up with a bin of width of 10 makes perfect sense, right? It's just super easy. Then I gave you some really ugly numbers, right? So this is 2017 baseball stats. And we looked at home runs. And I said, let's make some there. And when we looked at this list, the lowest number of home runs for this group of players, I think, was 2. And the highest number, I think, was 58. Am I remembering that right? 59. So we had from 2 to 59. Now, could I start my first bin at 2 if I wanted to? Yeah, but that's going to give me weird, ugly numbers, right? So where did I start my first bin? I started my first bin at 0. Could I end my last bin at 59 if I wanted to? Sure, but because they all have to be equal width, if I went from 0 to 59, am I going to get nice round numbers? No. So what did I go to? What did I go up to? Not 59? Yeah, I went to 60. Now, could I teach you some formula to figure that out? I guess. But isn't it just kind of better to think about it? Just use your common sense. I trust you guys. You got good common sense. Now, if we're going from 0 to 60, how wide should I make my bins? Yeah, you could do by tens. And so you'd go 0 to 10, 10 to 20. Absolutely. Nothing wrong with that. What else could we do? All the way up to 50 to 60. I think, is that what we actually did yesterday? We do 10 wide? Sure. But what could I have done if I wanted to? Sorry? Yeah, I could have easily gone 0 to 5, 5 to 10, all the way up to 55 to 60. Yeah. I could have done 12s if I want to, right? Anything that divides nicely works. 60 divides by 12. So I could have gone 0 to 12, 12 to 24, all the way up to 48 to 60, right? Doesn't matter how you do it. Does anyone have any questions about that? There's no magic bullet for how wide or how narrow to make your bins. It's kind of up to you. By the way, if you're ever working at a business and you got to make some reporting, try the bins a bunch of different ways and see which one makes you look like you're the best at your job. And which one should you use?
The one that makes you look like.
Well, you could do that, I guess, but I would suggest using the one that makes you look like you're doing a good job. And you'd be amazed. We're going to do a whole class about that, where I give you some data and try to see if you can manipulate it to make it look better or worse than it really is. Because it's an interesting thing to know about statistics. You always have to watch. How are they spinning this? Right?
So they really are lying.
Yeah, absolutely. You have to be careful. If you aren't smart enough to understand how statistics work, people who are smart enough to know how statistics work will use them to take advantage of you. That's the reality, right? They'll use you to sell you things you don't really need, or they'll use them to tell you that you need this service that you don't really need. People are smart. You got to be smarter. Because it's a sad truth about life, but the truth is there's people out there who will, manipulate data to lie to you, to deceive you. That's real life. So that's right. And what would just putting water in your mouth and swishing and then spitting it out get rid of, right? Should be the exact same number. It's like toothpaste. Why does toothpaste have soap in it for suds? It doesn't do anything to clean your teeth, but you feel like you're not washing your teeth properly if it's not all sudsy. And then because it's got that, they've got to pack like sweeteners into it to counteract the awful bitter taste of the soap. So none of that stuff does anything. You can just wash with pure baking powder. It does the exact same job, right? But we've been sold and told that we need these things, so there they are. Anyway, so here we made a histogram for that. And then we also looked at some numbers that are less nice, including negative numbers. Histogram can include negative numbers. So we talked about weight gain and weight loss in our, a puppy? Right? Everyone loves puppies. Okay. So today is like the second to last full lesson this week. We're going to spend some time on the computers. We're going to spend some time working with our survey data. Then we're going to get out of this evening and move on to quite a greener pastures. But today we want to talk about what a histogram can look like and what that tells us. So we call these distributions. When we look at the shape of a histogram, we call that the distribution of the data. And we're going to look at a few specific examples. Yep. And you're here sitting there. You're here sitting there. Very well. Okay. Did I put this on here? Oh, I did. Look how organized I am today. Oh, you want one too? You are so needy. Look at me. I want the note. Give me the note. Probably expected to get fed at home too, and I need water to drink. Oh, aren't you special? Okay, so here's the deal. Rather than have you guys work out of the textbook, because I hate that, I did it for you. I went to the textbook and I got some data. So they have, can I tell you why I think, pet theory, why I think most people hate math class? I think it's textbook questions.
Yes.
And can I tell you specifically what I think it is? And this one isn't, this textbook cover, I mean, I don't know what the hell it is, but at least it's bland.
But it's also good to beat people away.
Sure, but I always feel like the cover of, especially like grade 9 and 10 textbooks, they always put like some kid on a skateboard. And it's like they think they're fooling you. They think like, oh, look, that kid on the cover is skateboarding. Math's going to be just as fun as that. And it's, you know, math's different than skateboarding. Or it'll be like a guy snowboarding. But really, it should be a picture of a guy like, I don't know, with a pencil and paper doing that. But that wouldn't be very exciting. And then math textbook questions are always like, Jimmy gets a new job and wants to plant a garden. If he's trying to math, and they're just these questions, you think like nobody would ever do that. And I have this feeling that like, if we just did math for the sake of math, instead of trying to falsely pretend that it applies to our real lives, when sometimes it doesn't and sometimes it does, to me, the math that applies to real life, good, teach it. Teach how it applies to real life. And the math that doesn't, just be like, hey, this is something interesting we could learn. And it's math for math's sake. And that's okay too. But instead, it'll always be like, there's a guy named Dan Meyer, who's a math teacher. And he's quite brilliant. But he's got a website. And he puts up, every week he has his least favorite textbook question of the week. And my favorite one is like, the blue whale is a beautiful and majestic creature. It can hold its breath for 30 minutes and swims millions of kilometers in its lifetime. If a blue whale's tail can be thought of as two isosceles triangles, and it proceeds to ask you to like find the angle of a triangle, and you just think like, I hate this person and this question. So here we have, what's this one? Alice recorded the heights of people who walked into a hockey arena over a 2-hour period. Fun fact, if you ever sit in a hockey arena and record people's heights as they come in, security will probably ask you to leave. Just something to know.
Are you talking?
Especially like, well, no, I'm not. But I'm especially thinking, like, if I took my kid to a hockey game and some person, and Alice was there being like, hey, kid, how tall are you? I'd be like, can somebody get Alice out of here? I don't think I feel good about Alice. So anyway, that's just, this is my note, that, like, math textbook questions turned Alice into a creep. But creepy Alice does this. And, like, she asked lots of people. Good Lord, look at this. Yeah, so there we go. So I've gone ahead and put this into bins for you because she took a lot of data, okay? So I've already tallied it for you. Isn't that nice of me? You're welcome. Totally already tallied. Well, they didn't have the square and round brackets, so I helped you there. Yeah, you're welcome. But they also didn't give you graph paper. Yeah, who gave you graph paper? Right on your own page. This guy.
What if we wanted our square back on the other side?
Too bad. No, because you have to decide that before you tally, right? Have to decide that before you tally. Otherwise, you don't know what to put where, right? That's very important. So what I want you to do is this. I want you to make a histogram from this. And keep in mind, your Y scale is going to have to go how high? Y scale up to 41, and your X scale from 100 to 200, right? So try and divvy it up as best you can. Use a ruler. I'm not going to use a ruler because I can't on my screen. But do a nice, careful job. Rulers are here if you need one. But go ahead and make a histogram for me. Okay? Make a histogram of these data. Your pencil can find them right over there, my friend. But we're doing like a whole lesson and like ask questions. What?
Using a protractor as a roller for days.
I'm happy to.
How is this entertaining? Only those existing like bar cry.
First started my
This can only go poorly. I'm ready. Hey, that was pretty good. Huh? Look at that.
I do have some.
Whatever, do what you like. Doesn't have to be the same as mine. Who am I that you do? Who am I that what I do has to do what you do? I'm just a guy in an ill-fitting dress shirt who tells you he knows something about math. Okay, how many categories is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bins. Sorry?
My co-op.
Yeah. Oh, this is always X? Oh, whenever you're given a table of values, it goes in alphabetical order. So X and then Y. And you think about it, when you imagine a histogram, it's going to go up and down, right? So your bins are going to be along the bottom. Yep. I get to 40. So. Hi, how are we doing? How are you? Doing good. Really good.
5, 10, 15.
So I've set up a scale up here. This is by no means the only way to do it. You can set up yours however you like. But if you're feeling a little lost how to set it up, this is one way that will work. All right, and basically I went from a little below my lowest value to a little above my highest value. You could go from exactly your lowest to exactly your highest. Nothing wrong with that.
Okay.
Yep.
If you're not starting at 0,
Yep.
and you start at 90,
Yep.
and then go by 10, so you have to like put a break.
So here's the deal. On the y-axis, yes, you would have to. In the case of a histogram, on the x-axis you don't, because there's no assumption that a histogram starts at 0 on the x-axis. We do assume it starts at 0 on the y-axis, so we show a break. For a histogram, you don't have to show a break if your x-axis starts somewhere other than 0. Having said that, if you showed a break, that'd be fine. It wouldn't be wrong. But it's not required for a histogram. Did that answer make any sense? Okay. Yeah. Nothing wrong with that. Yeah. Yeah. It is just as correct. If instead of how I've labeled it in black here, you prefer to label this thusly. Nothing wrong with that, right? Totally cool. In fact, maybe I'll put that in here. You definitely don't need both of these. One or the other is good. But I will put both so we have it. Please tell me I'm putting the square brackets on the correct side. Am I backwards? Or are you just being difficult? Okay. Yes. Yeah, absolutely. I'll ask when I'm not recording what you did. Maybe. And?
I mean, they're good, but you gotta stick to them.
Well, yeah.
You're talking about like Walmart and like the cutout and then
Well, now you're making me feel self-conscious.
well, I'm just they're good.
It's what it is.
I was like watching it in the kitchen, and then when you start going off about your daughter going to dance, and you're charging your car and getting like almost different policies.
Yeah. Well, listen, that's exciting for me.
That's like 6 minutes of what could have been teaching.
Yeah. Can I tell you something? And take this or leave it. The tangents may seem totally random, and some of them are. But often they're not. I mean, what I talk about is random. But here's what I think. If I came into a chemistry class and spent 75 minutes throwing new chemistry at you, you'd get a little chance so the brain melts. You know what I'm talking about? Like when a teacher just stands in front of a room and just talks about the topic at hand for 75 minutes. Do you stay tuned in for 75 minutes? Because I'll tell you something. I got an attention span of roughly 10 minutes. And by minute 11, I'm thinking about other things. So I discovered early in my teaching career, if I teach for 8 minutes, and then tell a small anecdote about my dog, and then come back to teaching, and then tell a small anecdote about a high school teacher I had, and then teach for a bit, and then maybe do a Sean Connery impression. Those little breaks, just those little breaks, help people to not feel like, oh my God, he's going to talk about chemistry for 75 minutes. So instead I talk about chemistry for 55 minutes, 60 minutes, and people's brains stay in their heads. That's my thinking.
Now another secret.
Yeah, this is my theory. Now maybe I'm wrong. Maybe it would be better if I just went for 75. I don't know, but that's what I do. Okay, maybe you're done and way ahead of me, but let's get started if we can, putting this on together. What's the first value I have to put in? What's the first value from that tally chart? Okay, and where's that go? That goes between 100 and 110, right? It goes up to 5? Is that true? Okay, so there we are. What's the next one? 8? Now, my scale doesn't have 8 exactly on it, so I'm going to have to do my best guess, right? What's the next one between 120 and 130? 16? So like that. And between 130 and 140? 25 exactly? Nice. And between 140 and 150? Oh, big jump. Okay. And next. 41. Is that our highest value? I hope it goes down after that, because I'm running out of room. All right, what's the next one? 34. So maybe like that. All right, and after that? Oh, wow, big drop. Okay, 23 would be like there. And next? That's probably a little high. Sorry about that, but that's okay. Next? 8. And is that it? Between 200 and 210? There we go. Hello, come on in. Hi, are you doing recycling?
Yeah.
Thanks very much. Okay, so I'm going to color this in too because I can. But while I do that, let's talk. What do you notice about this graph? How would you describe it? Okay, and then we have to go a little smaller for this one. Come on. Thank you very much. Okay, so you should have a graph that looks like this. I mean, it's not going to look as beautiful as mine because, let's face it, that's real good. But what do we notice about it? What do we notice about it? It's got a peak. Good. And that peak is where? Right in the middle. Okay. Now, I always struggle with this, so let's see if you guys can do better than I. I'm sure you can. But with a curve this shape, you can pretty much draw a smooth curve through the middle. Nope. Nope. I mean, eventually, but not in this unit. So we can draw a smooth curve through this. And we call this even dumber. We call it a normal curve. Well, because we're going to talk about curves that aren't normal after this. So we call this the normal distribution. The normal distribution. What does that mean, normal distribution? Does anyone know? Anyone have a guess? I mean, I guess there's no reason for you to know. You haven't taken this before. Yeah. Yeah, so it's going to have a peak. It's going to go up and down. And the peak is going to be in the middle. So, very good. It has a distinct peak. In the middle. And that's one half of it. The other thing about this is not only is the peak in the middle, but what else is true about this? Or almost perfectly true about this? If I took a mirror and stuck it right down the middle of this, yeah, it's pretty much the same. So it is pretty much even on each side. And what's the word for that? When something can be divided in half and is even on each side, it is symmetrical. Very good. Oh gosh, 1M or 2? I always get this wrong. Is it 2 M's? Is it? Why does that look really weird to me? Is that right? Okay, I'm going to trust you. I'm going to trust you. And years later, when I share these notes with another teacher, if you're wrong, they'll judge me, not you. So you've got nothing. Do you know something interesting? I don't know what the DSBN is blocking, but the DSBN has blocked whatever server it is or whatever port it is on the network port that Cortana uses for voice recognition. So I'd have to type it in, and I don't have that kind of time. But it makes me feel crazy. At home, I can just talk to my tablet, and it gives me answers. And then here, the other day, I was mixing some chemicals, so I had a breathing mask on, I had gloves on. I was like, hey, Cortana, and then I asked her a question, and she couldn't answer, and I was... What?
Cortana to bring up video games.
Oh, that's probably true. Anyway, so it is 2 M's? Guys, you're good. I was going to fail you. I was going to go with 1. You didn't let me down. So this shape is called the normal curve. And when anything is shaped like this, we say that it is normally distributed. Okay, that's a phrase we want to know. So anything that has this shape is normally distributed. And you know what's interesting? A lot of things in life that you wouldn't think would necessarily have a pattern look like this. If you take everyone in the world's heights and you make a histogram, you get an almost perfect normal curve. It just works. Where there are more people of average height than there are really tall people and really short people. It makes almost a perfect normal curve. Same thing with shoe size. Same thing with IQ. Interesting, right? There's a lot more people with an average standard IQ than with a very high IQ or a very low IQ. This shape, very, very common. I'm trying to think of more examples, but in statistics, we expect, and this is interesting, it'll be interesting to see if this is what you find, but if you ask survey questions of enough people that have a numeric scale that you can make a histogram of, usually, not always, but usually, for so many things you wouldn't necessarily expect, you get a normal curve. In a normal curve, and this is something we hinted at the other day, but haven't yet talked about. On a normal curve, the last thing we're going to talk about is the mean, the median, and the mode go right down the middle. Does that make sense? So for a normally distributed set of data, the middle line is the mean, median, and the mode. And that is, in fact, the definition of a normal distribution, where we make a nice curve like this, and that line that cuts it right down the middle is the mean, the median, and the mode. So normally distributed data, the mean, the median, and the mode are all the same. Does anyone remember that from that activity we did the other day where we looked at the 2 curves and asked how they were different? How they both had a mean of 5, a median of 5, and a mode of 5. Does that ring a bell? That data was normally distributed. Right? It's almost like instead of sleeping, I spend my days thinking about how I'm going to teach this stuff to you guys, only to screw it up miserably when I actually have to get in front of you and teach it. And then telling stories about my dog. So there we go. I want you... Can I tell you? Sometimes I do. And sometimes those are the best lessons. Like I've had days where a piece of technology breaks or I can't get something printed or whatever, and you just go.
I find that when you get comfortable in doing one thing, that you start to get worse and worse at it.
I think there's something to that. You know, it's interesting. They talk about doctors. Young doctors are much more likely to make small mistakes, and small mistakes that have some negative outcomes. But in general, they're very, very careful. So, hey, Bird.
Don't do it, Miranda.
Excuse me?
I'll put it away.
Thank you. That was a better sentence than the first one. I liked that one better. But experienced doctors are less likely to make little mistakes, and they're much more likely to kill you. They seriously are. They're much more likely to make a big major mistake. So I think you're onto something there, where complacency can set in. Okay.
Next time I go to a hospital, I gotta ask my youngest doctor.
Well, the best situation to be in is at a teaching hospital where you got an older doctor and a student working together, where you really do, and that's what they found, is that in those situations, you get the experience and knowledge of the more experienced doctor who'll avoid little mistakes and little misdiagnoses, and you've got that care and attention to detail of the young guy who wants to make sure he doesn't make any mistakes and is crossing every T and dotting every I. And you put those two together, and yeah, they actually say teaching hospitals, where your instinct would be to think like, ooh, student? I don't know if student and brain surgery are really two sentences I want in the same, or two words I want in the same sentence. The fact is that the numbers show that they tend to be the safest combinations. That's the best place to be. Anyway, I want you to make a histogram for the next set of data on the next page. All right, we should be getting a little quicker, a little faster at this. So let's go ahead and make this one. See, look at you. Yeah, I think you're right, actually. I think there's wisdom in that.
They're all in one place.
Amy? So you said you'd put array, and now you haven't. So I'm going to give you one more time, and then I'm going to take it.
I just don't like people. Did you send them to small chats? Send that one day. Do you not remember it?
I'd be crying.
Okay, balls feels just worse. Just say worse. Yeah, let's stop the sorry. I'm going grab it. Matt?
Yeah.
Ladies, come on. You need to make a graph. Come on. Yeah. No, I got to talk you through it. When we're done these, you can work in the hall. But
She screamed at me like 5 times. No, I just got I told you.
What's your
So 100.
But you're in temperature because he pays to stay away.
With that scale, if I had the number 110.3, it would now have no hole. Does that make sense?
Yeah.
You now have a gap between 110 and 111. And the problem is, there's an infinite number of numbers.
Let's just make sure for us.
There's an infinite number of numbers.
Like a yellow.
Yeah, so the problem with that is just that it does not contain those numbers.
guys,
Much separate from the values that you? But I don't. I take that. I don't know. I have no idea what's going on here, but I see it. You said it. Yeah. Not gonna help to get behind the work. Have I ended your life?
Oh, guess we're not watching him.
Okay, let's start discussing first of all.
Do you want to take away my phone?
Just do it. Yeah. What if they just
No. What happened last time I was around?
Just do it.
He sat away in my room. They asked me to do something. I told them to go down myself.
Okay.
Oh,
not hard.
I got me.
Next.
Oh, look at you. Look at that.
And then I'll purposely sleep till 9 o'clock in the morning.
No, we're just doing
Because my
yeah.
phone
Alright.
at 1 o'clock.
Chelsea, how are your graphs looking? Why don't you go look in your chair?
Someone laugh at his face.
Come on. Go look in your chat. You can laugh at his face later. That seems like a weird sentence to say. But just look in your chat.
I mean, apart from the green tea, it's just happening.
Okay. So that this lesson doesn't stretch like till 5 p.m. Let's if you want to stay here till 5 p.m., I'll keep talking about math. But I have a feeling you'd probably like to get home at some point. So my first one, how high does it go? From 100 to 110. Whoa, what's going on? There we are. To 4. Okay. And my next one, Chelsea. What's my next one? Come on, hurry. How much? Sorry. Thank you. Sorry, I'm old and deaf. You gotta be sympathetic to that. Okay, Madam Soraya, what's my next one? 3. Okay. And gentleman at the back, where am I going next? 4. Okay. And after that? 9. Okay. And then 2. Okay. And just for the sake of niceness, let's do this. Okay, what do you notice about these data? What do we notice? There are 2 peaks. They're not evenly distributed. So we call this bimodal data. We call it bimodal because if I go to draw a curve through this, it's going to go up and peak twice. All right, and we call this a bimodal curve, and that means that if we would describe the data, we would say that the data are bimodally distributed. Bimodal distribution. Now, when we talk about numbers purely, when we talk about mode, we really mean just the most commonly occurring number, right? But when we graph it in a histogram, we can see that even if they're not exactly the same number, this has 2 distinct peaks. So this would be the first mode, and this would be the second mode. Does that make sense? Now, the thing you have to be careful about with this is where is the average going to be? Like, where is the mean value going to be? Well, you can't do that. You calculate average just the old-fashioned way by adding all the numbers up and dividing. But if we did that with this, where would the average person end up being? We got a lot of people way up here. We got a lot of people way down here. Where's the mean value going to be? Yeah, it's going to be in the middle, which is what's weird. The median and the mean are in the middle. And they're in the middle where the fewest people actually are. When we have bimodal data, we have data where the median and the mean are pretty crummy measurements, aren't they? Because they don't actually describe many people. You see this a lot. This is a distribution you get a lot on tests that you don't want. But you see it a lot. As a teacher, sometimes we see this distribution. If this were a test, who are these guys? These guys down here? Yeah, these are my guys who didn't study, didn't take notes, they did badly. And who are these guys up here? It's all the tryhards, right? All your keeners. Makes sense, right? And then not many people actually score in the middle. This, by the way, is how it works. If you have a class where half the people study and get ready and half the people don't, not many people do in the middle of the test. The people who study tend to do well, and the people who didn't study tend to do poorly. It's one of those things where we kind of say sometimes, there's no reason for someone to get 50 on a test. You know, 60, 70, 80, 90, sure. That means you studied and you had varying degrees of difficulty with it. You were varying degrees of ready. And then like 0 to 30, that means you didn't do anything. Right? Maybe you didn't even write any answers, you didn't take it seriously. But there's that middle area of like 40, 50, where it's kind of tough to fall naturally. If you answered all the questions, you'll probably end up somewhere over here. And if you answer none of the questions, you're going to end up, or just a few of them, you're going to end up over there. Does that make sense? And so sometimes when we give a test, we get this kind of bimodal distribution. Good. And maybe you guys can coach me so we can get this one done fairly quickly. How's this last one get set up? I need my ruler. Is it? I can never say the adjective form. Sisyphean is the adjective form of Sisyphus, and I can never get it out of my face. Okay, so how many bins do I need? 5? 1, 2, 3, 4, 5, 6. So we'll do every 3. And what's my starting value for this one? It starts at 0 and it goes to 6. And the next one? Oh, 50 to 60. Okay. No problem. So 50 to 60, then what? Does it go by tens? Great. Okay. And how high up do I have to go? Just as high as 6? So 1, 2, 1. Will that fit? I don't think that's going to fit. I'm going to be annoyed. Yeah, so I can't do that. Sorry. Flew too close. Forget Sisyphus. We're who's the one who flew too close to the sun? Icarus? Is that Icarus? Yeah, I flew too close to the sun. Look at you guys with your solid knowledge of classical myth. Deal. Okay, so let's fill this in. Okay, Newberg, 50 or 60, how many in here? Okay, 60 or 70? Okay.
2, 6.
Sorry, Ruby, I'm not trying to ignore you. I just
Oh
gotta
no,
finish
it's
this.
okay.
Okay, now, what do we notice about this particular curve? I am indeed coloring it, and can I say, at least on my screen, it's like a lovely lavender color. Actually, that one looks proper up there. It looks quite nice. I think I found my color scheme when I have to draw on the board. If I were going to draw a curve through this, what would my curve have to look like? It's going to be nice and gradual down here, right? And then all of a sudden it's going to go rah, like that. And that kind of sucked. Let's see if I can do better. That wasn't much better, but I'm going to pretend it was. Okay. What do you notice about this? Is it even? No, it's totally shifted to the right. This is a skewed distribution. So this is a skewed curve. And if we're describing not the curve but the data, we would say that it's a skewed distribution. Now, what I'd like to note here is in a skewed distribution, the middle of it will always be the mode, the most commonly occurring value. Where will the average be on a skewed distribution? Yeah, to which side? Yeah, it's going to be a little bit, just a little bit to the left if you work this out. Which might be counterintuitive, right? It might be counterintuitive, but the average is usually a little bit to the left of the big peak. Not always. If that second peak is really tall, it could be in the middle, it could even be to the right, but more often than not, it's offset. So the mean is offset from the mode. And the neat thing about that is when you have a skewed distribution, you have a case like this. Most people are above average. Doesn't that feel nice? Isn't that weird? It's a weird thing to say, right? You should think that half of the people would be above average and half of the people would be below average. That doesn't work that way with a skewed. That's true with a normal distribution, right? Half the people are above, half the people are below. And then, well, sorry, some of the people are exactly average, but anyone who isn't exactly average, half are above, half are below. But for a skewed distribution, most people are above average. So for example, can I take you back to a real world example? My grade 9 science class. What is the most common, what's the mode here? The most common outcome? People who scored in the 80s and 90s. Oh, that's a poor color choice. So this is the mode. Most people, the most common thing, but what's the average? Yeah, the average was 78. It was right there. And when I told them average, of course, I meant mean, right? The mean value. And so most people in the class actually scored above average. Kind of cool, right? So a skewed distribution is another very common one. We see the biggest skewed distribution I can think of, and you hear a lot about this in politics right now, rightly so, they should talk about it more, but we see a distribution like this when we talk about income, right? Most people, like if you take the median household income, it's something like $70,000, I think. That's for a whole household, so everyone in the house, right? But if you worked out the mean, the actual arithmetic average, it works out to be something like $245,000. And the thing that drives that up is there's very few people who make unbelievable amounts of money, right? People are making billions with a B of dollars in a year, right? And they drive the mean up, but the distribution's skewed. Most people make a lot less than that. Does that make sense? And again, a test is like that, especially with a class of people who are, you know, working hard and taking it seriously and trying to do well, and the teacher's making a fair test and fair questions. More people do well than poorly. That's what you want, right? That's what you hope you get. So those are the types of skews that you can see, left or right. This one is skewed to the, this one is skewed right. And if you want to do a little drawing of what skewed left would look like, you could have something like this. That's like the worst drawing ever, but whatever. That would be skewed left. Any questions about that? Stuff makes pretty good sense, yeah? Okay. Now, if it's not already patently obvious, what am I going to ask you to do with this newfound information? Yes, to her, not you. Specifically, what kind of work? Where is this whole unit headed? We are going to take the data we collect. So eventually, you should be able to take your survey data, and you should find the descriptive statistics. And when I say descriptive statistics, what's that mean? The statistics that describe your data, what are those? Mean, median, mode, standard, very good. Standard deviation. What's the other one there? Range, good. By the way, we call these, if you remember, measures of central And remember, it's a wordy thing. Tendency. Whoa. And we call these measures of spread. Guys, why am I talking over you? Shh. Like I'm not doing this for my health here. Yeah, shut up. Okay, so starting with the survey data, you should be able to give me all of your descriptive statistics. If you haven't done that already, you're gonna have to eventually. Might as well do it. So for all the survey data you've gathered, you should know for question 1, what was the mean answer, the median answer, the modal answer? What was the range of my answers? What was the standard deviation of my answers? Do that for both your questions. Then once you've done that, you should draw either a bar graph or what? It might make sense for your data to be a bar graph, or it might make sense for your answer to be a histogram. Good. And then once you've done that, you should be able to describe, what language did I use for this again? The distribution. Oh, if only. All right. So eventually you're going to have to do that with all of your data. So you might as well get started on that now. You all got 9 minutes. You can probably get all your descriptive statistics done. And that's a good start. Yes, ma'am.
I slept in this morning, hence why I was late.
These things happen.
Yeah.
Solid use of ents, by the way.
So
Hey, what are you writing?
I'm not here tomorrow because I have like a student.
No, that's for you. So
I'm not here tomorrow. Like I'm here, but I'm not like here. I'm feeling with the board for student voice.
oh, nice. Well, I mean, you are welcome. You're welcome to stick around now. But if you're
I have
busy,
practice now. Yeah. Thursday morning. I'm here. I get here at 7 in the morning. Or like tomorrow I leave
so let's
early.
do that.
Yeah,
Let's
so
say
Thursday
7
morning. Yeah.
when you get to Thursday.
Yeah.
By the way,
I'm
guys,
usually here before you actually.
I know you are. It's crazy. Most people are not.
Yeah.
I forgot to mention this. Tomorrow, oh, make sure you pay attention because then I know that you heard me and you can't say, but I didn't hear that. So listening. Tomorrow, you're going to have a quiz, short quiz, where I'm going to give you a little set of data, a little set of numbers, and you're going to do these calculations, except, I'm going to be honest, I'm not going to make you do standard deviation tomorrow, just because I don't want the quiz to take 3 hours, okay? So the one you won't do is standard deviation, because that's just time consuming, right? But other than that, I'm going to give you some data tomorrow and ask you to do all of this. Yes, ma'am.
Because your little homework had a lot of homework.
Yeah, that's good for you. That's how we learn.
A little bit of homework.
I called you psychopathic?
I do.
I mean, I thought it, but I never thought it came out. I always thought I managed to keep it on the inside.
No, I don't. We could try harder.
Can I tell you something, Chelsea? And this is legit. This is completely true. When I saw my class list and saw you were on there, I went, and I stand by it. And then I thought, well, I should start drinking now. Okay, hey guys, we should be sitting. It is not leaving time. Sit, get some work done. Yeah, you're working out there, yeah? Check on you. If I go out there and find you're not working, you'll be in here. That's less fun. Let's do it.
If I get my phone early.
I do get things. I am. I'm very school child.
Your parents think that is behind you.
I'm kidding.
You're not even wrong.
Something happens to you.
I think I'm a decent.
You're an alright girl.
I'm decent.
I'm not worse.
Really.
I know. You're a parent.
I am. I'd say like a solid B+ one too.
Oh, that's
Yeah.